Well, thank you for introducing a lot of the stuff. I'm going to focus in on one particular ag tech or food tech, and that is cultivated meat. That's something that we started about 10 years ago, and it has evolved over time. And it's the discussions that we had here show the complexity of the issues that we have to face. And it was mentioned yesterday a couple of times, I think, and rightfully so, that we cannot really think about one particular solution. We have to basically cover all our bases to get there. You are all past the 3 years that Martin mentioned of stunting. So who of you is vegetarian or vegan? And you're also very knowledgeable about food and all the consequences of... So no one?
Okay. Vegetarians.
2. Yeah, so that's roughly the average of the population. So, you know, it's kind of... Note that I didn't raise my hand either, right? I'm a deeply flawed person that cannot really live with the consequences of my own knowledge. So this is human behavior. It's very, very hard to change that human behavior. And some of the technologies that we are developing, in my mind, and I phrase it often as, it allows us to continue our sinful behavior without the negative consequences on climate and other issues, other externalities. So it has been mentioned, but not really to great extent yet, but livestock agriculture and meat consumption has increased over the last decades and is continuing to increase, according to the FAO, over the next 2 or 3 decades. Depending on, and we have discussed this yesterday, depending on the total population, but also on a change in diet depending on wealth in China and Africa and India. And we already have seen somewhat that livestock agriculture actually has a big impact on environmental resources. A lot of greenhouse gas emission, 14%, 80% of agricultural land use, 20% water use, and it goes on. Why is that? That is because animals are technologies, if you like, that convert feed into our food, and they are inefficient in doing so. So we spend a lot of resources feeding animals where we could feed people. So what is, I noticed yesterday that not everybody is aware of what cellular agriculture is or what cultivated meat is, so very brief one-on-one. We take cells from an animal. Those are the cells that actually make meat or make fat. We take them out of the animal and they have the capacity to proliferate. These are so-called stem cells. The idea is actually very, very old, but the stem cell description and technology has not been around for that long. They can multiply many, many times. There are different flavors of stem cells, but the basic one and the easiest to understand is just muscle stem cells and fat stem cells that are sitting in our muscle tissue and also that of a cow or a pig or a chicken or a fish. And they can proliferate. They can proliferate tremendously. And they can also, because they are designated stem cells for muscle and fat, they can make meat. So that's, in short, the technology. And I would like to, I'm not going to spend a lot of time on what the intricacies and the possibilities of the technologies are, but you can imagine that there is a lot of flexibility once you start decomposing the different aspects of meat and the tissue into different aspects, so you can start to play with many, many different technologies. I just want to show you what the current state of affair is. This started 10 years ago, and currently we have 160 companies worldwide. And Alessio just mentioned a couple already defaulted again, which is to be expected because there was a lot of late players also that actually really couldn't make it. But it's a tremendous increase. And it's very diversified geographically, as I showed in the previous, but also chicken, fish, pork, beef, and so forth. And what is currently happening, and it's somewhat delayed by what Alessio showed over the funding crunch, a number of these companies have started to build factories. So this is happening as we speak. It's still at relatively low pace, not at the scale that you eventually would want, but it's the factories, and this is within 10 years. This is actually quite astonishing how fast this has gone. One of the issues, maybe you remember when I presented the hamburger in 2013, that was a €250,000 hamburger. And so that was not really a product, if you like. And so the challenge, one of the challenges, there are a couple, but one of the challenges is to get the price down. Now, we are using pharmaceutical grade materials to grow a food product. That obviously is a no-go. And as you mentioned it briefly, you need to work on the supply chain, and fortunately, feed companies and food companies have very early on approached us and say, okay, can we supply feed or food for yourselves instead of for animals? So we're working together very closely to get those prices down. There are a couple of very interesting components that are in that feed that are extremely expensive, and that they don't have to be expensive. Like one of the growth factors, I kid you not, is 700,000 euros per gram. And it's not more intricate than insulin, which currently, pharma grade, is sold for 200 euro per gram. So there are ridiculous prices in there. They will lead to tremendous price reductions, and then of course, eventually scaling up will move it further. And in theory, this can actually be cheaper than regular meat because we use less resources in making it. If you think about the entire scale, mostly that cell production is essentially a fermentation system. It's a fermentation tank where the cells grow in large quantities in suspension. And in order to replace, and I think Alex didn't want me to use the word replace, but if you theoretically would replace the world meat consumption by this technology, you require 1.5 times the current fermentation capacity. Now, you may not be aware what that fermentation capacity is, and frankly, I'm not either. But you think about, wine, beer, all the fermentation activities that are in the world. So that's massive, but it's not unthinkable. It was already mentioned that this is a novel food. So it's a food that we are not familiar with, and we don't know the safety and all those type of things. So it has to be regulated, and worldwide there is now 3 products that are approved, 1 in Singapore and 2 in the US. And as mentioned, the FAO is actually, and this is unique, they are trying to harmonize the regulatory approaches in the different countries. Indeed, Singapore is taking a lead in that together with FAO. And this is quite unique that they're doing that. I'm quite happy to be part of that and think about how are we going to make this regulatory process more efficient. There is, of course, also a sort of interesting aspect of this, which is also kind of related to human behavior and acceptance. Would we be able to convince consumers to start eating this? And to be honest, in the beginning, I was also somewhat, it was unknown. Now we have a lot of surveys, and we have a lot of tests, and a lot of also coverage by media, and I think that this has shifted tremendously. At least the part of the world where I live, it has shifted tremendously. And it has shifted, I think, primarily for 2 reasons. One is that a lot of us already felt somewhat uncomfortable with eating meat, and this would be something to allow us to do that without burdening our conscience too much. And the other aspect is that, for instance, in the Netherlands, you cannot open a single newspaper on any day of the week without reference of climate change to livestock agriculture. So that time is changing and that acceptance is increasing. Would this actually lead to sort of an environmental impact? And I realize this is geographically very different, and it's maybe in other countries different than in others. There are a couple of life cycle analyses. This is a composite life cycle system of global warming, land use, water consumption, and fine particle matter. And you see that beef and dairy invariably end up with the highest impact. That's coming out of all the life cycle analyses. Cultured meat has two entries. One is with conventional energy and one with sustainable energy. So you see that there is a potential to improve this. And finally, I want to point out that you can use this technology not only for meat, but also for leather, which is another interesting concept, and also for other animal products, if you like. But these, I think, are the two most important ones to cover. With that, I would thank you, and
Mark, thank you so much.